So the question is, what's aircraft propulsion going to look like in the future? Well, the driving force behind it is trying to reduce the environmental impact, just like it is for all vehicles that burn fossil fuels. We're trying to reduce CO2 emissions and for aircraft NOx. Immediately, we're not going to see a massive change, because if you imagine there's a large amount of aircraft flying around at the moment, we're not going to see an overnight change suddenly to electric aircraft. It's going to be a slow and steady change. But there are a lot of changes, engineering changes going on at the moment. So your standard aircraft, when you go on holiday, is powered by a turbofan. That front fan is going to get bigger. That makes the aircraft more propulsively efficient. So we can burn less fuel. If we burn less fuel, we produce less emissions. But if you make that fan bigger, you've got weight issues, you've got all sorts of mechanical issues. So we're going to be looking at composite materials, gearboxes, all sorts of heat management issues. We're also going to try and push these cycles, the thermodynamic cycles, much further and harder and get hotter engines. So there are going to be cooling problems. We're basically taking what we've got at the moment and pushing it right to its limit. So perhaps the big changes aren't going to happen for the first 10, 15, 20 years, but after that we're going to see electric powered aircraft coming along. Not wholly electric, it's going to be a hybrid type aircraft with at least one jet engine or gas turbine, as we like to call them. That will produce much of the thrust required for cruise, but it'll be much smaller because it won't be required for takeoff. So to help the aircraft get off the ground, we'll have big electric fans which will be powered by batteries. At the moment, battery technology isn't quite good enough for this technology, so we're going to have to develop some better batteries and better energy storage. But that's the way it will go in the next 20, 30 years. So as well as going for higher bypass ratios, which means these big fans, we're also going to change the combustion system. Obviously that's where the fuel's burnt and that's where the emissions are produced. Traditionally, we've burnt our fuels quite rich, so a lot of fuel to air. We're now going to move towards burning them in a lean environment, so less fuel to air. That's problematic in terms of getting the combustion system to work, but if we can achieve that, we'll have a lot less emissions, particularly nasties like NOx, and it can be potentially much more environmentally friendly. So once we move towards more electric engines, we can actually make them smaller. If we can make them smaller, we can distribute them around the aircraft much more, which actually gives us quite a big potential for efficiency gains. Importantly also, we can start to integrate them into the airframe. So instead of having the traditional tube, wings and engines hanging underneath the wings, we'll start embedding them in the airframe. It's much better for aerodynamics, much better for noise, but it is going to require aircraft manufacturers, not just engine manufacturers, to work together and produce these next system of hybrid aircraft. So we have had aircraft like that in the past, we've had flying wings, but now we're looking at what we call blended wing body aircraft, where the engines are really part of the airframe design. These sort of aircraft probably won't be flying, you won't be going on your holidays in these aircraft for another 30, 40, 50 years, but it's certainly on the horizon. My name is Dr. Duncan Walker. I'm a senior lecturer in applied aerodynamics here in the Department of Aeronautical and Automotive Engineering. My particular field of speciality is gas turbine aerodynamics, and I work very closely with companies like Rolls-Royce looking at the next generation of jet engines.